Hey everybody, this is Mr. Brooks, and this is the video for multiplying and dividing radicals. And at BVLA year 21, we're on August 24th. So there's a couple rules you need to know when you deal with multiplying and dividing radicals. The first rule is when you multiply the outside number times the outside number, and then you multiply the inside number times the inside number. And you're going to leave the inside number inside the radical, and you're going to leave the outside number outside the radical. So you're just multiplying two sets of numbers. Now, after that, you want to simplify, okay? And you could technically simplify first if you wanted to. So if you want to simplify the radicals and then multiply, that's fine. You might end up having to simplify again afterwards. The other rule is with division. And that says that in math, you are not allowed to write a fraction with a radical in the denominator. And so if you end up having, through you're doing some calculation or something, and you end up with a radical in the denominator, you will need to do what's called realize the denominator, which means that you're going to remove the radical. And you're not changing the value of the fraction, you're just finding a way to manipulate it where the denominator does not have a radical in it anymore. And the way you do that is you multiply by the same radical, because, for example, the square root of 2 times the square root of 2 is 2. So it takes the radical away. And if you multiply the numerator and the denominator at the same time, like this right here, this is what I like to call a special one. And the reason it's a special one is you're really multiplying it by 1. And if you multiply by 1, you don't change the value, right? I mean, you're not trying to change the value, you're just trying to rewrite it. So if you multiply any number divided by itself, you get 1. And so therefore, when you do this process, you're not going to change the value. Okay, hopefully that makes sense. There's also a conjugate. We're going to get into this a little bit later. But if you had a binomial where you had like 3 minus the root of 2, the square root of 2, something like that, the way you would cancel that is by multiplying the conjugate. And so the conjugate of this is the same numbers. It's 3 and root 2. And it's the same numbers, but we just flip the sign. And it turns out that when you multiply by the conjugate, you're going to end up with a value that it does not have a radical in it. Okay? So for example, one more. If you had like negative 3, I don't know why I'm still using 3. Let's see. Can I, no, I can't. Let's say 8. There you go. Plus square root of 6, and then the conjugate of this is negative 8 minus square root of 6. So same numbers, different sign. Okay. All right. Now we'll clear selection. And all right. So here's one of them. It says, what is the product? So we're going to multiply. So I have 3 root 3. And this is going to be multiplied by 4 root 21. Like this. Okay. All right. Now, if you remember the rule, we're going to multiply the outside numbers times the outside numbers. So 3 times 4 is 12. So far, so good. And then the inside numbers times the inside numbers. So 3 times 21 is 63. Okay. And then, so that was easy. We do have to ask ourselves, can we simplify? So 63, the only number that comes to mind, I'm just not very good with my multiplication tables, is 9. It does work. So this would be 9 and 7. And that's 12. And that 12 just got brought down, right? Okay, so this is really 12 times 3, square root of 9 is 3, times the square root of 7, which is equal to 36 times root 7. And that would be my product. That would be the what happens when you multiply those, okay? So inside times inside, outside times outside. I said that in the opposite order I would do it in. And then simplify. Here's another one right here. So this is 5 times 8 root 200. Okay. And the outside numbers are 5 and 8, so 5 times 8 is 40. And the square root of 200 is just there. I mean, essentially, this is like saying the square root of 1. And so, I mean, if it's just, I mean, if there's no inside number for the other one, you just, I mean, it's just times 1. So it's just times itself. So this one, I know when I see anything in the hundreds, it's like, oh yeah, that's 100, right? And 2 and 40, and then this turns into 10. So 40 times 10 times root 2, which is 400 root 2. Now, you could have done this by simplifying. So if you had 5 times, this is 8 root 200, which would have been 210, that would have been 80 root 2, right? And then it would have been the same thing. You could have just multiplied 5 and 80, got 400, and then square root of 2. Oh. Okay, so here's an example of dividing. First off, let's talk about what this is not. Okay, you can't come inside the radical. There's nothing to do inside the radical. Okay, so you can't say that this is just like radical 6 over radical 1. All right, you can't do that. All right, but what you need to do is you need to, and also first of all, you could simplify. Okay, you could simplify. See if this 60 will simplify down. But the most important thing is you're not allowed to have the radical in the denominator. So if you remember, we're going to multiply by the denominator, root 10, and then what we do on the bottom we have to do on the top because it has to be 1. There we go. And then square root of 10, square root of 10. The pattern is it just cancels the radical. Okay. It means just whatever's on the inside. It's always going to be that way forever and ever. If you want to check the math, it's square root of 100, and the square root of 100 is 10. Okay, so this one would be square root of 600. And that's, inside times inside. There's technically outside times outside. It's 1 times 1, so you don't write it. And then this would be 10 root 6 over 10. That I got a little sloppy. I'm so sorry. Okay, so the square root of 600 is 6 and 100, and so 100 breaks down to 10, so it's really 10 root 6. And then now this is going to cancel 10 and 10. You can cancel the outsides right here. This you can reduce your fraction. That's the better way of saying it. So it's just root 6 over 1, and anything over 1 is just that, root 6. Okay, here's a similar one. You have to realize the denominator. And so, you could simplify the top first, but why? Well, I mean, you might not like the big number, but so remember, this is just 5. That's all it is. Just take the number and put it in there. You don't have to do it if you can see the pattern. So 480 times 5, I'm gonna need a calculator for this guy. 2400 okay, and then let's see. It's gonna break down 2400. Let's see if that will oops. I'm gonna have to do this the long way just because I'm not gonna be able to think about it. But let's see, 2400 is 100. Or if I can just do 1,000. 400 divided by 1,000 is 100 times 100. Nope. Okay, so it's 124, which is this is 10, and then this is 4 and 6, which is 2, so it's 20 root 6, which is this is 20 root 6, and this is the same 5, and then this is so 20 and 5, this is what we're going to look at here, and if you reduce that fraction, that is going to take you down to 4 root 6 over 1, and since it's over 1, you don't have to put it in. Okay? All right, so that's how to do it, and hopefully that helps. Good luck. Let me know if you have any questions.